Hello and welcome to this presentation on UML diagrams. In this session, we will dive into the concepts of class and sequence diagrams, two essential tools in the unified modeling language used for system design. Let's get started. UML or Unified Modeling Language is a standardized way to visually represent the design of a system. It helps developers, designers, and business analysts communicate more effectively by providing a common visual language. UML covers several types of diagrams including class diagrams, sequence diagrams, use case diagrams, and activity diagrams, each serving a unique purpose in system modeling. Class diagrams are used to represent the static structure of a system. They illustrate the system's classes, their attributes, methods, and the relationships between them. A class diagram serves as a blueprint for objects, showing how they interact and are related within the system. Let's break down the key components of a class diagram. Class diagrams contain several types of relationships. First, we have generalization or inheritance, which is represented by a line with a triangle pointing to the parent class. For example, a manager is a type of employee. Next, there's dependency, which is a dashed line showing that one class depends on another. Finally, multiplicity, which describes how many instances of one class are associated with another, like how one customer can place multiple orders. Let's look at an example of a class diagram in the context of an e-commerce system. Here we have several classes: a customer, a product, an order, and a payment. Each class has attributes like the customer's name or the product's price and methods such as an order or processing a payment. These classes interact with each other to complete the e-commerce workflow. In our e-commerce system, there are key relationships between these classes. A customer can place many orders, forming a one-to-many relationship. An order can have many products, which is a many-to-one relationship, and each order has a corresponding payment, forming a one-to-one relationship. These relationships are fundamental to the operation of an e-commerce platform. Moving on to sequence diagrams, while class diagrams represent static structures, sequence diagrams focus on dynamic interactions between objects over time. They show how objects communicate with each other through a series of messages or events. Let's take a closer look at the components of a sequence diagram. Here's an example of a sequence diagram for an e-commerce order process. First, the customer requests to view products. The system responds by sending the available products. Then the customer selects a product and places it in the cart. Afterward, the system processes the order and the customer proceeds to payment. The payment service processes the payment, and finally, the system updates the order status. This diagram shows the flow of messages between the entities involved. Now let's practice creating UML diagrams. Imagine you are designing a library system. We have several classes: a book, a member, a librarian, and a library. Each class has its own attributes and methods, such as a member's ability to borrow books or a librarian's role in adding and removing books. Your task is to draw the UML diagram for this system. In the library system, a member can borrow multiple books, forming a one-to-many relationship. The librarian manages both the books and the members, ensuring smooth operations. The library itself contains many books and members, showing how the system is organized. Let's visualize the borrowing process in a library system with a sequence diagram. First, the member searches for a book. The library checks if the book is available. If it is available, the member borrows the book. The librarian records the transaction and the member receives the book. This diagram shows the sequence of interactions that occur when a member borrows a book. To summarize, UML diagrams are essential tools for visualizing the structure and behavior of a system. Class diagrams provide a static view showing classes and their relationships, while sequence diagrams focus on the dynamic interactions over time. We have also looked at a practical example and an exercise to help solidify these concepts. That concludes the presentation. If you have any questions or would like to discuss any of the concepts further, feel free to ask. I would be happy to clarify anything you need.